Okay, welcome to this video answering Edexcel Decision Mathematics AS June 2024 question 3. So we've got this question here and we've got this network. Looks like quite a big network. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 12 vertices on this network. And actually this question starts off with a relatively straightforward question. So the question is asking us what is meant by the term tree. And there's two important facts for a graph to be a tree. First of all, a tree is a connected graph, which means that there exists a path from any vertex to any other vertex. The other important thing that you need for a tree is that there are no cycles. And once you have both of those being true, we've got a tree. So tree is a connected graph with no cycles. Question B, part 1, and we're asked to use Dijkstra's algorithm to find the shortest route. We have a bit of an issue. We've got some unknowns. We've got x and we've got y. But we're told that x and y are integers, and that 9 is strictly smaller than x, which is strictly smaller than 14. Which is strictly smaller than y, which is strictly smaller than 14. So, we know that y must be smaller than or equal to 13, and we know that x must be strictly smaller than y. So we know that x must be smaller than or equal to 12. Similarly, we can go up the other end. We know that 9 is strictly smaller than x, which means that 10 is smaller than or equal to x. And because x is smaller than y, we know that y must be at least 11. So we know the fact that x is between 10 and 12, and y is between 11 and 13. So let's get started with Dijkstra's algorithm. So we're going to start at vertex A. So I'm labelling vertex A first, and the distance from A to A is 0. So I'm going to calculate my working values. I'm going to get 2, 9, 14, and x. 2 is the smallest working value, so I'm going to visit B next. And I'm going to update the working values of all the vertices connected to B. I'm going to get 7 for C and 14 for F. 7 is my smallest working value at a vertex that's not being visited. So I'm going to visit C next. And it has a final value of 7. That means the working value of F gets updated to 13, G gets updated to 30, and H gets updated to 22. The next smallest working value is either going to be 13 or x, but x is between 10 and 12, so x is next. Which means a working value for j is x plus 6. So x plus 6 is between 16 and 18. So I'm just going to make a note, 16 to 18, just below it, really small. Okay, my next smallest working value is 13, so I'm going to visit that one next. And I'm going to update the vertices connected to it. So K gets a working value of 15, and G 26. D is next, with the final value of 14. So H gets a new working value of 21. K is next with 15, which means that M gets a working value of Y plus 15, which is currently between 26 to 28. Just as a little note. Okay, I've got 4 cells of working values. I've got 16 to 18, 21, 26, and 26 to 28. So J is next. And I'm labelling J 8th. So h is going to get a working value of x plus 7, which is between 17 and 19. H now has the smallest working value of any vertex we've not visited. So h is 9 with final value x plus 7. So I'm going to update working values. G is going to get a working value of x plus 13, which is between 23 and 25. L is going to get a working value of x plus 12, which is between 22 and 24. X plus 12 is smaller than x plus 13, and both of those are smaller than y plus 15. So I'm going to visit L next, and M now gets a working value of x plus 15, which is between 25 and 27. G comes next because 23 to 25 is smaller than 25 to 27. So G is next with a final value of x plus 13. Adding 10 onto this gives me x plus 23, which I know is smaller than x plus 15. So M is last with value x plus 15. So I know that the length of the shortest route is x plus 15. And backtracking, I've got x plus 15. Subtract 3 is x plus 12, and I actually forgot to put the final value in. Always make sure to do that. Backtracking gives me x plus 7, and because I've got x's in, I know I need to take the path with all the other x's in. Back to 0. So the shortest route is A, E, J, H, L, N. So you get 1 mark for attempting Dijkstra's algorithm. So as long as it appears that you've attempted it somewhat reasonably, that's a mark. Your next mark, A1, is for getting A, B, C, E, F, and K entirely correct. Your next mark, which is another accuracy mark, is for D, J, and H. The next mark, another A1, is for G, L, and M. And then finally, you get 2 accuracy marks for the shortest route and the length of the shortest route. Okay. Part C. The warehouse manager wants to check that all of the workways are in good condition, and their route starts at B and finishes at C. And we need to inspect the entire route. So this is a route inspection problem, so I'm going to label all of my vertices with their degrees. I've got 4 for A, 3 for B, 5 for C, 4 for F, 2 for K, 3 for M, 2 for L, 4 for G, 5 for H, 2 for J, 2 for E, and 2 for D. So there are 4 vertices with odd degree: B, C, H, and M. But the route starts at B and finishes at C, so B and C need to have an odd degree for the route to be able to start at B and finish at C. So we just need shortest route from H to M. And we need to traverse that shortest route twice. And the shortest route from H to M is actually on our shortest route from A to M. So we know it goes H, then L, then M. So we need to traverse the edges HL and LM twice. This is actually only an independent accuracy mark. Okay, D coming up next. State the number of times that H would appear in the inspection route. And what I'm going to do is I'm going to add on HL and LM again. And looking at H currently has a degree of 6 if you include the edge HL twice. So H has degree 6. So if H has degree 6, that means that it must be visited 3 times. Why is that? Well, every time you visit H, you must come into H and out of H, which uses 2 edges. So we can only visit H 3 times before we use all 6 edges. If a vertex is a starting vertex or a finishing vertex, you only need to use 1 edge for the starting visit or the finishing visit. So because you only have to leave B, for example, or enter C once. Then finally, we're told that the entire length of the inspection route is 172 metres. And we know the total weight of the network currently, so we know that 139 plus x plus y plus the weights of HL and LM, because we're traversing those twice, is equal to 172. And we can solve this. This is giving us that x plus y is equal to 25. And there's some solutions to x plus y equals 25. You could have x equals 1 and y equals 24. Unfortunately, 1 is too small for x and 24 is too large for y. So let's consider x equals 10. So if x equals 10, then y equals 15, which is not correct. If x equals 11, y is equal to 14, which can't happen. And if x is equal to 12, then y is equal to 13, which can happen. Finally, x cannot be larger than y, so these are the only pairs we can really consider for x. And we can see that x equals 12 and y equals 13. And this would score you 2 marks. You'd get a mark for writing down this equation here, and a mark for giving the answer. So thank you for watching this video, and until next time, goodbye.